So guys, this time has come, and after almost 2 years I'm recording the second video in the topic of architecture. Yeah, that's because of war and pandemic and other stuff. So basically don't have much time to write articles and record videos on that stuff. So today we will talk about URL shortener service. It's a typical interview question for architecture, and you may find many different solutions on the internet, but on this example I want to talk not about technical part of that solution, but mostly about how the system design process look like and what crucial part it have and why they are important. So we are starting every solution from our business case and talking with business. Why it's so? Because all things that we will do, it's just tooling for business to make money, and from that money we get our money. So if business doesn't get money from your solution, then maybe you will not get it also. So that's why we work with business very coupled. So what our shortener service should do here, we describe some requirements based on business case, functional, non-functional requirements. Also we'll describe some business limitation, for example, time, money, people resources and other stuff. Why it needed? Because, for example, we have only Python developers, and architecture thinks that we need to use Golang for some reason somewhere. And if we will not say that we can't hire Golang developer, then there will be a problem. So all this limitation also should be here. But because we don't know limitation of example solution, so there are no business limitation, only some small of them, just for functional requirements. So what it should do? Of course it should redirect from original URL to from short version URL to the original URL. Maybe it will have some customization, for example, short IO custom name URL. Users can track simple analytics like use number using the admin key generated when we basically add a new shortened URL. Users are limited to adding up to 10 URLs per day, for example, to not DDoS our solution with too many URLs from one user. The service should be capable of handling 1 million requests per day. It's not so much as you may think. The service should be able to scale up or scale down easily, so we will use something like scale groups or things like that. Shortened URLs should be saved for a period of 2 months. This is basically one of the business limitations that we have. Why it's so? Because if you see how you share your information, you will understand that in most cases, links that you share needed for you for mostly a week. After that time, nobody will click on it, because most of the URLs saved in social networks, and social networks updating too fast, and data for a week will be very at the down of all this data stream. So we said at 2 months, it's a pretty big amount of time for URL, and after the time this short URL will be deleted, and we can use this URL for example for the next URL. That's not our business limitation, and based on this limitation I will show you some simple interesting hack for that. On the step 2, we basically writing down our key performance metrics and our constraint, and here you must understand that you will have this constraint and metrics for different stage of your system and business. For example, we describe in some limitation and metrics for launch time, but you will have something like middle time and like load time. When middle time is like when you have most of the achievable users from your market, and load time, for example, when you get whole the market for some reason and you were very lucky. So we have limitation pretty straightforward. From like response latency less than 50 milliseconds, we may understand that we all may need geo-replication. Uptime for nines, we may need some good login tracking and other things like that. Server load 80%, it's for scale up, scale down things. Analytics lag time up to 10 minutes because our users, that's not a user from Google Analytics or system like that. They will come up to our stats page not very often. From our constraint, let's assume that read-write ratio we have 100 to 1. Basically we have 99 million requests for read and 1 million for write. We have linear load. That means that we have same load, for example, for day and night and for every hour. In real life it may be different. In most cases it will be different. We have read RPS about 1000 something and write RPS only 12. It's very small number. Bandwidth also pretty small, and only one network adapter will handle all this stuff. If you look at our database storage and our cache, that's also not very big numbers, and one server can handle all this stuff together. Next step is our data, and here you must understand that in this step we describe only data. We don't describe any schemas, relation, or anything like that many people trying to describe like in the first step because they came up from like object-oriented programming or thing like that. Why we don't describe schemas or relation here? Because we don't know about anything about our infrastructure, our system, like how data will go or where it will be saved and things like that. So we can't say what we need to do with it. So that's why we're saving just our data objects, and for our solution it's just 2 objects and very simple. On step 4 we're describing like third-party components that we may use. It's not like that we'll use them on 100%, just like limiting the number of things that we may need to understand like from what amount of things we will choose our solution. For example, for database we can use DynamoDB, ScyllaDB, Cassandra, Redis, Couchbase, things like that. For cache, Redis, LS, Elasticache, Memcache. Here you must also understand that you should choose software and solution patterns and other things based on your experience. If you don't know how this thing works, you should hard test it before use it, because in other case you may fail at not very good point of like system life. For example, I had experience with Cassandra, with Redis, Couchbase, DynamoDB, but I don't have experience with ScyllaDB. I read some developers' reviews, look at some benchmark from the developers of ScyllaDB, and they look fine. But I know that in most cases people lie about benchmarks, especially when this benchmark are made by the company who made the solution, and I don't believe them. So before I will use ScyllaDB, I will test it based on my business case, based on how I will use data, what will load will be. So I'm trying to use it with maximum similar like behavior that I will have in real life. That's very important. After that, when I have data on my hands made by myself, I can say, will I use it or not? Or will I use it in some time when something will basically fix it? And that's very important thing because many people use some services, some software without understanding like the dark side of the services. For example, as I said in previous video about Kubernetes, that many people saying how Kubernetes is like good solution, but not so many people saying about the problems that Kubernetes bring to them and how hard to manage all this stuff together, and why this solution are good only for like really big companies and really big teams and not some small startups. So after that we can describe our high level design. We basically use here some helicopter view on our system. We don't need some precise or details here, just simple understanding that we will use after that to start asking questions to ourselves and going deep in details, describing our architecture more and more deeper. How this looks like, we'll see in step 6 when we basically do this stuff. So before doing something, we need to ask question to ourselves, how things will do, how they will behave, what the like protocol may be. Another thing that came up to our brain. For example, can Redis handle the anticipated load with good read latency? For example, I don't know. What I can do, I can test this and then answer. If answer no, then I need to came up with some solution to mitigate this problem. How we can replicate Redis cluster to a different geolocation? For example, yes, free version of Redis cluster doesn't have geo-replication. It only accessible in enterprise solution for which you need to pay, which is not a very good thing. So what we can do, we can write our like proxy servers, some proxy servers that will basically do this replication for us, as Redis use very simple protocol. It's not a big problem here. Forget to say something about our high level design. So we'll use here our geo application. For that we'll use DNS servers that can handle basically can understand the geo region of the user and move it to the near region that we have. We'll break our services on two, management service and redirect service. Management service is basically for adding, administrating the URL by the user, viewing the statistics and things like that, and redirect service will be using only for redirecting user from short URL to the original URL. Also, we will not replicate the management stuff to our geo region, basically maintaining all this stuff only in main region. This will decrease the amount of money that we'll use, simplify our solution, and basically we don't need this from business perspective because we need speed when we redirect an user. But when user adding the new URL, it can wait for some time, and it's okay. Also, we'll have some key generation service that will generate some keys for us that we can use for adding new URL. I mean short keys. And maybe some cache, I don't know. We'll see after asking ourselves this question. So you understand what type of question we may ask. So I ask myself some of that question. For example, about key generation service. how it can will look like, and most solution on the internet suggesting like creating some additional database for that service that will handle like free usage URLs, things like that. It's about like 2 to 30 gigabytes of memory that may be used. Also, we need to maybe replicate this stuff, and so it make our solution harder. What we may use instead is basically to use a simple counter, saving just a few bytes in database. As we have limitation like 2 months for saving the URL, it's like the best solution. It basically resemble a round-robin algorithm. So we have in our URL 7 symbols. It's about 9 billion combination from AAA to ZZZ. And let's assume that AAA is number 1 and ZZ is at number 8 billion something. So in such case we can just save the counter like 1, 2, 3 and so on, and then represent this counter as some 7 symbols. The only thing that you may monitor here is that your adding rate is much less than your URL capacity. If not, then you may need to add some additional symbols and update your algorithm, but it's pretty simple solution for that. So as I said, we have like 2 months limitations. That means that, for example, for one day we have 1 million new URLs, and for 2 months it's like 60 million URLs. That means when we come up to 8 billion URL on our counter, our like few millions of URLs on the from the index 1 and so on will be already free to use. Also, why we use Redis for our solution, it's because it gives us thing like TTL for our keys, and we'll delete our URLs from the data store automatically without like adding additional scripts or things like that. Also, it very fast, save data in memory, have some replication on disk if needed. So for our current solution, I think it's the best thing that we can use. Why I don't use AVS Elastic Cache? Because I like to manage things by myself, because when you use managed services, it's okay for cache, but when you use it as database, you may need access to your database and do different things, like for example adding some additional modules to Redis, make data replication in some cases differently than Elastic Cache will give you ability to do, and things like that. So better to run all this stuff on EC2 instance and control all this stuff by yourself. About view statistics, we add additional view service here to mitigate the problem of like more robust solution in future. Also, this will limit some resources for writing to database. And here we have 2 solutions that came up to my mind. First of all, we may limit number of like writing tasks to our database with stats incrementing by saving all these incrementing stats on each redirect instance, and have some additional thread that will with some time update this data in database. In such case, for example, we may need to write few things per few minutes, for example. The alternate method that I remember from like many years ago, and which was popular in many like statistics services when I was like just starting my career, it probabilistic probabilistic method. Idea here is such. For example, you have probability of 20%. That means that once in 20% you will write data to database, incrementing your counter, but you will increment it not by 1 but by 5. Why by 5? Because you divide 100% by 20% and you will get the 5. So basically in such way you decrease the number of writes to database. The problem here is that this approach not so good with small numbers, but it's very good with reasonably large numbers of data and requests. The main problem of it is that it's random. So at some cases it may be situations that all these services will write at once to the database, and we can't control such situation in this solution. So from my perspective, it's not the best case right now. So we will use the first one. Another thing that we may understand here is that we have basically two choices to do. Save our statistics on main server only, or save it across all replicated clusters, and then aggregate this data when user need it. It depends from the amount of traffic that we have and amount of statistics that we save. So you may understand that geo-replication is seen when you say passing your packets from one point in the world basically to another point in the world, basically like from China to USA, and it's a pretty big latency there, and channels that you passing the traffic through them are not very big and speed not very big. That means that you can't handle like big amount of data through this stuff, and you need the way to limit this data. And what you can do is basically save this data locally, and then through the aggregation during the read this data when only it needed. Aggregation data and reading data, it's on, for example, for Google statistics, is less often than writing this data to database. So in such case you will decrease your load on the system. For our solution we don't need such thing. We have only like view statistics, and it's pretty simple, and we can handle like pretty big amount of load, and also we're not saving like each of them, we're saving them in batches, so there will be just a few requests for some time, so we can use such solution. Also we'll use like Docker container deployment. Why? Because you need to understand that you pay not only for servers, but you also pay for time of your specialist, and testing, deploying, security testing and other things is much simpler to do with containerized solutions. Sorry for my language, I'm really tired for this day. Have many things to do with my cats and work. So container solution will like very simplify life of your developers, and they will thank you for that. We will not use any like Swarm or Kubernetes services like orchestration, just Docker on the or another container runner that will just run single instance. And with all this stuff we came up to our detailed plan, as you see. So what we have here, we have AVS WAF for limiting number of like writing requests to our management servers. for user per day as we have in our requirements. We have our statistics server, management server, redirect server, case generation server, data servers inside auto-scaling groups that use CloudWatch metrics that we write there from each service and our solution. We have our Redis database cluster. Our database data service basically doing all the stuff here, and in our solution basically a small bottleneck that we may have, but we don't have so much load, so it will not come for us for a long time. Also doing replication to our geo regions. We have also backup for our Redis database cluster, because there are only like 27-30 gigabytes which we can simply save. But you need to understand that in high load solution and big system you don't have the way to backup your data in most cases. And the only way to backup your data is to replicate services, data, and other stuff that you use. Only such thing will save you. So you can't like run, for example, cloud solution for file storage for many terabytes, and then just like backup it somewhere. It's just impossible. So here you will see that our redirect server read data from data service, but also have a backup connection. Why it's so? Because our data service can be down for some reason, and our like redirect functionality is a crucial functionality of all our solution, so it should work in most every cases of fail. So we have backup connection to our Redis database cluster, which will be used if data service will not respond at needed time. So it's not very detailed design. In most cases you will need to much more deeper detail, but for current solution, which very simple, it's pretty enough. But for big solution you may need to break your solution for some blocks, and there are a couple of ways of doing this. You may break block based on some tree of I would say service groups. What is service group? Is basically some service that consists of many different services. For example, if we have some big solutions that have URL shortener, then this whole system will be basically one service group. Why? Because it realizes some functional thing, for example, show the URL, that may be used in other bigger system as just one like functional, like one function, for example. So you can break based on that, or you can break based on logic if you have like lighter solution, or if the structure of your system given you such possibility. What is logic breaking? Is basically when you have some user case, for example, add new URL, and you write design for only this case. For example, what services you will need to accomplish this task. You don't include other services for that. In such cases you will have like solution from the start of your use case to the end, and it's very good for understanding of processes also. If you don't have such way to do it, then you break your solution based on service group and add additionally schema for your processes for each use case. After that, you will need to do contingency planning, and that's the thing that many architecture and developers for some reason don't do. I don't know why, because it's a crucial thing for every system design and architecture. What basically we need to do here is ask ourselves what we will do in case when some shit will happen, and what plan to mitigate this problem do we have. For example, what if start service will fail? So in such way we can save I don't know, I don't remember if I said before. We'll accumulate some stats views inside each instance of redirect service. So we will not write to the start service from on each view. For example, every 10 minutes we'll write through additional thread data to the start service, and it will write it to the database. So what if start service will fail? Then we can accumulate this data for a longer period of time if memory gives us such possibility. If not, we may save all this data to the disk or to the S3 bucket, or for example some SQS and when the start service will come up, we'll just read all this data with aggregation from that sources and save them to the database, something like that. What if data service will fail? In such scenario, we can stop adding our URLs, or for example just writing them to the some wall log that will be used by data service after it will come up for saving data and replication. But we will use our redirect service backup connection to Redis cluster. Why? Because redirect service is a crucial part of our system and basically the main functionality, and it should work like most of the time, as I said. Adding URLs can like wait for some times. From business perspective, you need to understand that losing your current users is much worse than losing new ones. So saving saving URLs that you already have much more important than adding new ones for our case. So you asking a question like that and planning what you will do for such situation, making additional change to your structure of your system design. Here you may also add some risks that you can't mitigate with some solution. For example, if someone will hack your system and steal part of your data or all your data, what you will do, what like risks on money do you have, or things like that. For such thing you can use factor analysis of information risk. It's pretty cool stuff for that. You may find some tool written in Python here that basically will create some report like that will give you understanding how crucial this like problem to you or not, and what you basically will need to do with that problem if it will came. So after all this stuff, you need to document them. Why? Because you are not the only person in the team, and other people should know what they need to do and how they need to do this thing. Also, the main problem here in like startups is that many team leads or architects that work in there don't write documentation and leave this documentation inside their mind. and this create basically bottleneck for developers. So if you have team of 2-3 developers, it's okay, they can ask your lead. But if you have like team of 100 developers, of course they can't ask the team lead, because he can't like have so much time to answer all this stuff, and also he need to do his own job. So this will be a bottleneck. Also, if your like team lead will die or go away from you, you'll have also big problems, because nobody will know what is doing, what system is doing, and how processes are coupled. That's why always write documentation. Especially when you describing something, you already write this documentation inside your mind. Just write it down on paper or inside of Google Notes or something like that. You will thank to yourself in future, I guarantee. In many situations, I forget like some part of systems that I did, or some processes and other stuff, but I have notes on that, and reading notes give me all the information that I need in few minutes. And restructurizing the data from the start will like can take like few hours or a few days, which much more bigger time. After writing documentation, you need to develop like development and integration plan. This plan you develop with your business. Why it's so? Because integration plan is based on business strategy of going to market. For example, we in our system we have like something like 3 parts that we may deploy in different times. First of all, our main part is adding and redirecting the URL, of course. The second part, geo regions. From the start of the service, we may not need them, because we don't have so many users to cover all the stuff. For example, starts of the service can be added much later, because also it's not the main functionality of our solution. So basically we can deploy this solution in 3 steps. Why it's better? Because from startup experience, I know that the sooner you get a feedback from your users, the better. Why so? Because you may think that something that your system needs something, but in reality, a user will say that they don't care about that, and they need something another. And in such case, you can like save some amount of money on development things that will not be used by your users. Another situation, and when you basically develop something and your business is going down, and you just save some amount of money that you could pay for development of some system that will never be used. After development and integration, analysis, all this stuff, what you should write down is how you will control your development process, your systems that already integrated. Why so? Because when you're developing something and think about something, that's not the same that people around you will think the same. Even if you have the most precise documentation that may exist in universe, still some people will think slightly differently, and with time this difference will be increasing. And what you need to do is decreasing this difference between your planned solution and real solution that you have in life. Also, you may need to develop your system with additional version, for example, version 1, version 2, version 3. Why? Because business development, some things changes, requirements changes, and this is also need some control to understand that it's time to move something out and replace with other thing. Why? Because you always have risk of some software that will like shoot you in a leg with some amount of time, and you need to plan this time, so before it shoot it, you replace it on something newer, something better, faster, and things like that. So I hope it was pretty okay, and most of you understand what I trying to describe here. If not, or you have another question on the architecture and development, please ask in the comments below, or on any social networks where I exist. For example, Facebook, LinkedIn, TikTok, Instagram, YouTube, something like that. Hope it was useful for you. Also, please take a look on Twitter timeline videos that I posted 2 years ago. It's also very cool. I'm describing here how the Twitter timeline may work and like structured. Many people like it, so hope it will be useful to you too. I hope to write some additional article on graceful upgrade for services on Ubuntu through the deb packages on the next week, and hope proceeding on doing some articles and videos on architect topic in future, and not like in 2 years the next one like this one. Hope all things will be going fine. So thank you guys, and have a nice day, evening, or whatever you have.